now that we've learned about the Pythagorean theorem of statistics, let's do the speed dating problem again. So what we have to do first of all, identify that our, let's do mu. So mu of male is equal to 68.5 inches. Standard deviation of male is equal to 4 inches. Mu of female is equal to 64 inches. Standard deviation of female is equal to 3 inches. We have established that male and female heights are independent because these are a bunch of random strangers in a room. Male and female heights are independent because speed daters are strangers. Okay, it's not like there's a bunch of people from the same family and maybe their heights are related. Okay, so we can apply those rules, the Pythagorean theorem of statistics. So we know that the mean of male minus female is just 68.5 minus 64, or 4.5 inches. And the standard deviation of male minus female we find by doing the square root of the standard deviation squared of male plus the standard deviation squared of female, and that ends up being 5 inches. So now our distribution of male minus female heights is a normal model, and we know that when we subtract two normal models, we get another normal model. So we have here a normal model with mean 4.5 and standard deviation 5, and we want to know how likely it is that the male height is greater than the female height for a randomly selected pair. We could also state that as the probability that male minus female is greater than 0. So often you'll be asked, is one random variable bigger than the other? You can say, then is their difference greater than 0? Because you have to introduce a number in there to calculate a probability. So if the mean here is 4.5 and the standard deviation is 5, I would expect 0 to be somewhere around in here. So I'm looking for the shaded area under the curve here. And remember, when we did our simulation, we calculated it as being about 81%. Now we'll do normal CDF, and we'll go from 0 to infinity with a mean of 4.5 and a standard deviation of 5. And it turns out that this is equal to 0.82, so our simulation was very accurate. So about 82% of the time, a randomly selected pair will have a taller male. Okay, now what about variables that aren't independent? Let's look at one more example here. Let B equal the amount spent on books in the fall semester for a randomly selected full-time student at El Dorado Community College. Suppose that mu of B equals 153 and sigma of B equals 32. Then let C equal the cost for tuition for a randomly selected full-time student at the same college. Mu of C is $832.50 and sigma of C is 103. Pretty inexpensive community college here. Find the mean and standard deviation of the cost of tuition and books. So we're adding the two together for a randomly selected full-time student. This question really doesn't apply here because I don't even really talk about shape in here. But say if they were normally distributed, which they're not really in this case, but if they were normally distributed, we have a normal distribution. However, we're not going to be able to do this problem anyway because we have an issue. We could say that mu of B plus C is mu of B plus mu of C. However, when we go sigma of B plus C, we can only add variances. In other words, we can only use the Pythagorean theorem of stats if B and C are independent. However, in this situation, cost of books and tuition are not independent, because a person who takes more classes is going to pay more tuition, and they're also going to pay more for books. So if tuition is higher, then that will affect the cost of the books and vice versa. So cost of books and tuition are not independent. So for the purpose of this introductory course, you would not be able to do the problem. Now, you may recall from math class that you know that a squared plus b squared equals c squared if there's a right triangle. But if there is a non-right triangle, an oblique triangle, you still have a relationship that applies. A squared plus b squared minus 2ab cosine of c equals c squared. And that's called the law of cosines. So there is the equivalent of the law of cosines in statistics for dealing with a situation where the two variables are not independent. However, that is beyond the scope of the course. So I just want to let you know that just because we say no, we can't do something in this course doesn't mean there isn't a way to do it. It just means it's not something you're going to be held responsible for knowing. So for right now, if the two variables are not independent, then you are not going to be able to calculate the standard deviation. Something else I wanted to mention, which I forgot to mention earlier, is that the rules for the standard deviation and for adding the means apply to more than two variables. So what if I had x plus y plus z and I wanted to add them together? Then it would be add together the two means. Or if I had x plus y minus c, I would add together x and y and subtract the mean of z. But no matter whether I add or subtract, I would just continue to add their variances. So I can add more than one. So I could add variance x plus variance y plus variance c. I could do this standard deviation squared of x plus standard deviation squared of y plus standard deviation squared of z, take the square root of the whole thing, and that would be the standard deviation of all three variables combined. So that applies to more than one variable.